Hi, welcome to my video on method resolution order in Python. I'm Srikant Pregada, trainer and director Srikant Technologies. In this video, we understand what is method resolution order, for short MRO, in Python. Unlike other languages like Java, C Sharp, Python supports multiple inheritance. So you can create a class from multiple classes. But then when we call a method, from which of those superclasses the method is taken? This is what method resolution order is expected to resolve. Let's look at different cases. Let's understand how MRO works in each of these cases. I also have a blog on the same topic. I suggest you go through this blog either before or after this video. And if you have already gone through that, then this video will give you more explanation about it. And after this video, if you go through the blog, you have some code which you can reuse. Let's get started. Here are some cases. To start with, my first scenario is where class C is derived from A and B. A is having a method called process. Doesn't do anything. It just prints a message A process. B has nothing. When a class has nothing, we can give pass to indicate it has nothing. But if you are not giving pass, it's a syntax error. So make sure you put pass. C is derived from both A and B, and now I create an object of C and I call method process. So in this hierarchy, C is derived from A and B. So all the methods of A and B are inherited into C, and right now only A contains process method. So when I say call process with an object of C, this method is called. Let's just check that. Run it, case 1, and you can see A process. So you're able to invoke process because it is present in superclass. But what if you have a slightly different scenario? In this case, I have the method both in A and B, and C is derived from both A and B. So what happens if I say process with an object of C? So the question is it coming from A or is it coming from B, or are both of them called, or is Python confused and saying I don't call it from either? Well, the answer is, let's check out. A process. So it is going to take the method that is present in A, which is the first superclass. So the rule says it is going to decide which method to call in the order of inheritance. So C is derived from A and B, but A is the first superclass. So Python takes the method from A. Remember, both A and B have the method, but it is going to take it only from A because that is the first superclass. But in case if you don't have it in A, if this is not there, then it would automatically take it from B. So when you have A and B as superclasses, if both of them have the method, the one that is present in A will be taken. If only B is containing, A is not containing the method, then obviously it comes from B. There is another interesting scenario. What if the method is present in C as well? What if I have the method in C? Let's create the method in C. And now I say print C process. Now what? Well, you can guess. And the rule is simple. Always the most specific version should be taken over generic version. So anything in A and B is considered to be generic compared with what we have in C. You know, inheritance is all about moving from most generic to most specific. So when you're moving from A to C, C version is more specific than A version. So it is going to call now the process method which is present in C. This is a very important point. Whenever there is a more specific version, Python always considers most specific version. So C version is more specific than A and B, so it comes from C. Well, that's just another scenario. Now let's talk about another case where I have A, B, and C is derived from A, B, and D is derived from both C and B. And you can see hierarchy of this kind here. This is what I'm talking about. So C is already a subclass of A and B, and D is derived from both C and B. Now what if you have to call a method? Let's get there. The method is present in A, B, and the method is present even in C, but it's not present in D. Now which one should I take into account? Now the rule says, if you go back to this, the rule says if the method is present in D, it should be taken. Otherwise, it has to take it from its superclass. Now my superclass is C, and C itself is having A and B, two other superclasses. Now it actually goes in this way. It will take the first superclass, and if a method is not present in that superclass, then it will go to second superclass. And D is having C as the first superclass and then B as the second superclass. So the rule says if the method is not present in C, all the superclasses of C, then it will look for method in other superclasses of D. But in this case, anything that is present in A and B is present in C. So D derived from B doesn't make much difference. So if you come back to this and run, the one that is present in C is called because C is most specific. But what if I don't have it in C? That's going to be interesting. What if I don't have in this? If I remove this, and then if I just put pass, because I told you, you got to have some statement. Now A, B, both are having that, and C is not having it. And D is derived from C as well as B. So B is one of the superclasses and C is another. Let's go run. And it is coming from A. And if you see what it is, D is not having the method. Look at that. I'm calling the method from D. D is not having the method, so it should go for A. But C is going to inherit all the methods of A and B. C is inheriting whatever is there in A and B. So Python will go to C and will look for the method in the first superclass of C, which is A, and it will get it from there. And if it is not found, then it will go to next superclass. So this is the way it goes. But now the case 4 is little tricky. Now this is where we are talking about a different scenario. And let us see this. Okay, here, this is case 4. I have A as a superclass of B and C, and then D is derived from both. This is a diamond. So how does it work? Let's go. So here I'm talking about A, and B is derived from A, C is also derived from A, and D is derived from both B and C. This is exactly the diagram you are seeing here. Now, let's look at this. I try to call process method. So which process method should be called? If you go by the previous rule, when the method is not present in D, it should come from the first superclass, that is A, but A does not have the method, but its superclass is having the method. So you should be getting the method that is present in A because that is present in the first superclass. Now C is the second superclass, but it has the method. Now, if you talk about what is called as MRO, MRO is nothing but the order in which Python is looking for method. So it starts with the D. After this D, it will go to B because B is the first superclass. And B is again derived from A, it goes to A. And don't forget there is another superclass for every class, that is object class. Every class in Python is implicitly inheriting object class. Well, this concept is very common. You see it in Java, you see it in C#. So we are talking about object class also. So after A, it'll check for that in object. And then it'll go to the second superclass, which is C. And then it is going to go to its superclass. What is the superclass of C? A. And then again we have the superclass object. So it should start with D, go to first superclass of D, then its superclass, then it should go to second superclass of D and its superclasses. Now, if you go by this, the method process should come from A because that's where we have the method. But if you run this program, you're going to see the method coming from C. Why? Why the method is coming from C, not from A? This is the most important part of MRO. This is called full-blown order. But this is not the order followed by MRO. So if you talk about MRO, this is not the order. What's wrong with this order? You have a superclass ahead of its subclass. So in the order, we should not have any superclass before its subclass. So A is superclass of C and it should not be before its subclass. And this is the most important point. The point is a class should not be before its subclass in MRO. So I have this A, which is a superclass of C, and it cannot be here. So what Python is doing, it's removing it from the order. Of course, object is supermost, so it cannot be here because all these classes are subclasses. So it is also gone. So the new MRO is going to be D, then followed by B, the first superclass, and followed by not these two, instead C, and then we can have A because now there is no subclass after A. A is superclass and there is no subclass after that. We only have the superclass of A, which is object. So this is the way MRO is built. The finer point here is you cannot have a class before its a subclass in MRO. So we have to remove this and this from MRO, and that leads to this. You're left with this B, C, A, and object. That's the order. And you're starting with the first superclass and then going to the second superclass. The problem here is both these classes are derived from A, but A should not be before C. It can only be after C. So with this on your mind, if you go and run the program And as you can see, the method is coming from C. And if you want, you can even ask Python to print MRO. So there you are, d.mro. It's going to display the MRO saying D comes first, then B, then C, then A, and finally object. So you can always find out in which way Python is looking for a method in the context of multiple inheritance. This is the most important part when it comes to Python and multiple inheritance. So make sure you understand the way MRO is built. That's an algorithm and they have designed it in that way. Now coming back, so that's fine. Now look at this scenario. Seems to be very simple. C is derived from both A and B. So guess what happens if you try to call a method that is present both in A and B? Well, here is my scenario. A is superclass for B, A is also superclass for C, and C is also having B as a superclass. So C is derived from both A and B is derived from A, and this is exactly the hierarchy you get to see. Now in this case, what is going to be the MRO? Take your time and try to understand how MRO can be constructed in this case. Well, you might be thinking it's going to be C, and then it's going to be A because that is first superclass, and then it is going to be the second superclass, right? Now, if I put it in this way, will it succeed? So C, A, and B. Can I have A before B? Can I have A before B? Now that is the question. A cannot be before B because B is derived from A. How can you have a subclass after superclass? No, you can't. So it should be C and then B and then A. But even that is not valid because I cannot have the second superclass before the first superclass. I cannot have this B before A. A should be considered always first, only then it should go to B. So this is not valid because I'm having superclass before subclass. I can't go with B and A because this is not consistent with the order in which Python is looking for the methods. It should always start with the first superclass, then it should go to second superclass. So what is this? It's pretty tricky. Neither I can go with the first nor I can go with the second. Yes, that's exactly the case. When you go and run, you get a message saying it cannot create a consistent method resolution for A and B. That's it. So there might be cases where your multiple inheritance can cause this kind of inconsistency. So it cannot create any MRO if you have it. Well, the remedy is you just change the order from A to B to B to A. So say C is derived from B first and then A, then there won't be any issue in creating MRO because now it's going to be C, B, and then A. Of course, always at the end your object class. So if you are talking about the previous order, A and B, you have a problem. You run into a scenario where you just cannot have any consistent MRO. Well, so be aware of these tricky situations, and you have these minor issues when you deal with multiple inheritance. Now, one last case I want you to understand about multiple inheritance is about the super keyword and constructors. Generally, when we use super keyword, not a keyword in Python, please remember, it's not a keyword, it's a function. and it is calling superclasses init function. Generally, when I say super function, I get access to superclass, and then I get access to a method in the superclass. But in this case, I have two superclasses. So which superclass method is it going to call? I want to call init method of a superclass, but which superclass is it going to take? Now, if you go and run this, you understand it's coming from the first superclass, because this is also using MRO, and it uses MRO and it will take the init method coming from first superclass. But what if you want to call both these classes init methods? I want to call init method from both A and B, because sometimes it is needed to initialize both the superclasses. Then your super function is of no use. Instead of using that, you have to use A and you have to use B. But the problem with this is, when you are using this A and B, you must provide self as a parameter, because you are calling the function with the class name. Then self is not automatically provided, so you have to make it explicit. So this is where you're going to call both the constructor of A and constructor of B. But even there, you have a small issue which can be a problem at times. And if you try to see what is the type of self, you might be expecting self to be of type A, generally the case. But in this case, what you're passing is an object of C, because in the context of C, self is an object of C. So when you run this program, you are seeing it is of type C. So sometimes this can land you in trouble, because you expect an object of A, but what you are getting is an object of C, because the self is what I'm passing from here to constructors. Well, multiple inheritance does give you a lot of advantages, but also it has certain issues of this kind. Be aware of it. So that's about method resolution order, or MRO. Do read my blog, and this is providing the same details. But if you like to read, and this is what you should read, and this is the URL where you find it. And if you are interested in any course on Python, I have a couple of courses, and these are my courses, and I provide all the courses online as well. Anywhere in the world, you can join me, because the courses are provided online and it's live instructor led. So you have more details about my online courses available here. If you click on this, you get information about how my online courses work. So this is the course where we talk about everything about Python, and also how to build web applications using a fascinating framework called Django. That's about MRO. Keep working on that. Get clarity about how Python is internally deciding which method to use. All the very best. Keep learning.